Okay, guys. Today we are going to be continuing section 8-5, which was adding and subtracting rational expressions, and it segues into adding and subtracting and actually combining complex fractions. Now, a complex fraction, as you can tell, it's pretty complex. It is a rational expression that has at least one fraction in its numerator or denominator or both. For example, this guy right here has two fractions in the numerator and a fraction in the denominator. For sure, it's rational. This guy here has a fraction in the numerator and in the denominator. That's a complex fraction. And of course, this one here has two fractions in the numerator, two fractions in the denominator. That's going to be a complex fraction. Whenever you have at least one fraction in the numerator or denominator or both, it's called a complex fraction. Basically, it's fractions of fractions. But it's really not that bad. I promise you. Yes, sir. Yeah, the first one would not equal 1. Please do not start jumping to conclusions here, guys. This is easy, but it's not that easy. There is a procedure that you must follow. Your tricks and your shortcuts, please put them aside. This is not the time for shortcuts. This is the time to do it the right way. I promise you, I'm going to show you two different methods to do these. And whatever method works out best for you, that's the method that I want you to use. Okay, I'm not here to dictate to you how you have to do it. All right, I'm just going to show you what to do. And I'm going to show you two different methods. Okay? So, let's get right to it. Bless you, son. Okay, let me go ahead and actually take this guy, put him over here. I'm going to show you two different methods here, guys. I'm going to show you, we'll call it method 1, and then I'll show you method 2. Method 1 is always the easiest. You can use method 1 about 80% of the time. You can use it 100% of the time, but 20% of the time using this method, it's going to make it, believe it or not, more complicated than not. So I'm going to show you both methods. Whatever method you like, run with it. But don't forget about the other method, because there's going to be situations where your method is going to be a little bit tougher and you're going to want to do the other method. So let's call this method 1, okay? And this, I believe, in my opinion, is the easier of the two, okay? This is all you got to do. 1, find the LCD of all denominators. And I mean all denominators, both in the numerator of the complex fraction and the denominator. So when I say find the LCD of all denominators, I'm talking about all denominators. You feel me?
Yeah.
Sir? Okay, this whole thing is technically a numerator. This whole thing is technically a denominator. Okay, however, within this complex fraction, in my numerator, I've got these denominators. And in my denominator, I have this denominator. Right? Because I have a numerator and a denominator in both the numerator and the denominator. That's why it's called a complex fraction. Great question. Thank you. Sir? Like, okay, what my boy asks is, let's say that the whole entire denominator was, let's just say, 5x plus 3. You'd only look at these two here. Because in this case, the denominator just had a numerator. The denominator of this is 1. You feel me? Okay, thank you. Thank you very much, guys. So, first find the LCD of all the denominators of the individual fractions. Yes. Yes, very good. The LCD here is xy. Very good, guys. Now, here's the easy part. Step 2. Multiply the LCD to everything. Everything, period. To everything. So, what does that mean? That means I'm going to multiply this whole top numerator by xy and this whole denominator by xy. So, when I go ahead and distribute, what's xy times 1 over x? No, it's y, because the x's cancel. What's xy times x over y? X squared. Because the y's cancel and x times x is x squared. Then what's xy times 1 over y? X. And then what's xy times 1? Plus x. Y. Are you guys with me so far? Yes, sir, my brother. Yes, sir, my brother. What's up, Baba? Yes, sir, my brother. This is a distributive property, yes, is what this is. Because I'm multiplying that to everything in the numerator and everything in the denominator. Correct. Look, guys, this would have been xy over x. The x's cancel, so I'm left with y. Xy times x is x squared y. But divided by y, the y's cancel, I'm left with x squared. Xy times 1 is xy divided by y, I'm left with x. And xy times 1 is xy. That makes sense, my brothers? Okay, and then finally you simplify, if possible. So here I could rewrite this as standard form, x squared plus y over x times y plus 1. I just factored out an x to the denominator. I did put the y, son. This is all we're going to do now for the rest of the day is practice. This is it. This is all we're learning today. Complex fractions. That's it. I just finished saying that all we're going to do today is examples. That's what I just finished saying, sir. But thank you for asking me to reiterate. I factored out the x, Papa. Standard form. Highest to lowest exponent. Thank you. Okay. Whoa. Whoa. No. Relax. Okay, no worries. Let's just continue. Oh, yeah. You know what? Yeah. Let me show you the other method first. And then I'll show you. And then we'll do the other ones. Okay. The other method, believe it or not, some people are going to find easier. And that's okay. That's why I teach both. In the second method, my brothers, this is method 2. Okay. What you have to do is add the numerators first, then the denominators, then stay, change, flip. So, for example, what's the common denominator of this numerator up here? xy. So I got to multiply a y to top and bottom here to get xy as a denominator. And I got to multiply x up here. Right? So this skill is just what we just finished learning. Learning how to add complex fractions, or rational expressions. So I'm going to get y plus x over xy. Does that make sense so far to everybody?
Yes, sir.
Yes, sir, my brother. Here, okay, for the down here, the denominator, the common denominator is y, right? So this is going to cancel to be y over y, correct? So this is y plus 1 over y. Is everyone with me so far, gentlemen? Talk to me, bro. Sir. No, I guess you guys are in a repeating stage today. No, I had said that you can do it any method that feels good to you. Thank you for asking me once again to reiterate, though. Now we're dividing fractions. Stay, change, flip. So, stay, change, flip. Guess what? This y cancels out with this y. So I'm left with y plus, wait, no. Wait. This should be x squared. Sorry. Y plus x squared over x times y plus 1. And if you look at the split screen here, they're both the same exact answer. Does that make sense, guys? Hello? This guy and this guy are the same. Yes, sir. Yeah, x squared. I know, and I have made a mistake, and I fixed that mistake. Yes, sir. Shh. Guys?
You do the LCD. If it's not a full number as the denominator, what would you do?
What do you mean the whole number as a denominator?
Because when you did the method 1, you got it so like you canceled out, so there was no fraction with the denominator.
Right, yeah, that's always going to happen because you're multiplying by the GCF. So one of the denominators is always going to cancel. It's always going to happen like that. Always. So I don't know which method you like better, guys, but that's both methods. So let's check out 10 here, okay? Now in this case, you can use method 1 or method 2. Why don't we do them both ways? And then hopefully you guys can really make your decisions. So let's do method 1 on the left side of the screen, and let's do method 2 on the right side of the screen. So method 1, okay, what's the LCD here? XY. So remember, I got to multiply everything by the LCD. The LCD is XY. So I'm going to multiply everything by XY. What's XY times X, my brothers? X squared Y. Okay, now look, when I distribute, XY divided by X would equal Y. Good job. X plus XY divided by Y would equal? Okay, you're done. You're done. Sir. Doesn't matter in that case. You can put Y plus X or X plus Y. In this case, it doesn't matter because they both have the same degree, sir. Thank you. Now, let's look at method 2, okay? Example 10, method 2 now. Let's see which ones you guys like better. Okay, X, you leave X alone because there's nothing to add there. And then you have 1 over X plus 1 over Y. My LCD for that is XY still, correct? What do I have to multiply to 1 over X to get the LCD of XY? Y over Y. And what do I have to multiply to 1 over Y to get an XY? So then this is going to equal X over Y plus X over XY. Are you with me? Now, you're going to do stay, right? Change, flip. And then that's going to give you X squared Y over Y plus X. I don't know about you guys. Oh my goodness. You cannot cancel out individual pieces of binomials. You cannot cancel this X with that X. No. Because we're adding, man. Come on, dude. Get on the train of success, man. Come on. Gentlemen, do you see the difference here between method 1 and method 2? Method 1 is a lot easier. Method 2 is exactly the same thing. Very good. Very good, my brother. You're exactly right. What he said is completely true. They're both the same, bless you. It's just that method 1 condenses it a lot quicker. Makes it a lot easier. Let's look at one that's a little bit more complicated, please. I'm sorry, you had a question. I'm sorry. Okay. Okay, now, let's do the next question, guys. Let's do number 11. Okay, let's see what we got here. Okay, this one's a little bit more complicated, but not too bad, okay? It's actually, let's leave it here in the center. It's not that bad. What's my LCD? Check it out, guys. Look, this is how I always check it out. I look for all the different things. Okay, I've got an x in the denominator, so I know I'm going to need 1x. I've got an x plus 1, so I know I'm going to need an x plus 1. And I've got an x minus 1, so I know I'm going to need an x minus 1. That's it. That's my LCD. Good job. Okay. Now, remember, guys, I'm going to multiply everything by x, x plus 1, x minus 1. And everything here by x, x plus 1, x minus 1. In this case, you're going to see that it's a little bit easier for this one to do it method 2. And I'll show you why now. We're going to have to do a lot of work here, okay? That's why I think method 2 is going to be way better, and I'll show you. When I multiply x times x plus 1 times x minus 1 to x minus 2 over x, only the x's cancel, right? So I'm left with x plus 1, x minus 1 times x minus 2. Plus, when I distribute this LCD to this, the x plus 1's cancel, so I'm going to be left with 2x times x minus 1. Does everyone see how I got that numerator? No? When I distribute this to this, don't the x's cancel, dog? So I've got x plus 1 times x minus 1 times x minus 2. And then, when I distribute it to this guy, the x plus 1's cancel. So I've got 2x and an x minus 1. Right? Now, let's make this a little bit easier for us. What's x plus 1 times x minus 1? What does that turn into? X squared minus 1 times x minus 2 plus 2x squared minus 2x. X squared times x is x cubed minus 2x squared minus x plus 2 plus 2x squared minus 2x. So this is going to give me x cubed, that cancels with that, minus 3x plus 2. That's the numerator. That's the numerator. Now we got to do it for the denominator. So now when I multiply this to this first guy, who cancels out? The x minus 1. So I'm going to be left with 3x times x plus 1. When I multiply the LCD to this guy, who cancels out? So I'm going to have just a 1x times x minus 1. So my denominator down here is going to be 3x squared plus 3x minus x squared plus x. So this is going to equal x squared minus 3x plus 2 over 2x squared plus 4x. Are we done? Absolutely not. We have to reduce. So this x squared minus 3x plus 1, doesn't that turn into x cubed? Thank you. So I cannot do anything with that. Okay. We're good then. Go. What? Of course. What's up, Chief? What? Yes? Okay. This is a pain here, guys. I don't like this. Let's do it. Let's do it the other way. Let's do it method 2. And you'll see it's a lot easier method 2 this way. When they get really complicated, method 1 is not so hot. 1 minus 1 over x plus 1. Okay. Let's just go ahead and first add the numerator and the denominator separately. Okay? So for the numerator, what's the LCD for up here? is going to be x times x plus 1. So what do I have to multiply with this bad boy? X plus 1. I think I made a mistake here on this side. And what do I multiply over here? X. Okay, so let's go ahead and distribute this. This is going to be x times x is x squared minus 2x plus x, so minus x minus 2 plus 2x. All of that over x times x plus 1. Does everyone see that? Do you want to make it widescreen so it's bigger?
Yes.
Yes? Okay. Okay, let's do full screen. Look. It's okay, it's okay. Okay. Let's just rewrite it because when you're on half screen, it makes everything larger when you go to full screen. We'll just, oh boy. Okay. All right. Let me write it down. And that way you'll see exactly what we're doing. Okay. So we've got x minus 2 over x plus 2 over x plus 1 over 3x minus 1 over x plus 1. Okay. The LCD for this up here is LCD is x times x plus 1, right? So here I'm going to multiply an x plus 1. And here I'm going to multiply an x over x. Who does not see that? Okay. So my common denominator here is x times x plus 1. So I'm going to go ahead and write it down. Now guys, let's distribute. X times x is x squared. Minus 2x plus x is minus x. Then 1 times negative 2 is minus 2. Plus 2x. So in the end, my numerator is going to equal x squared plus x minus 2. Yes, no, maybe, kind of, sort of? Okay, now, down here. What's my LCD down here? X plus 1 and x minus 1. So, what do I have to multiply to this first term? X plus 1. And to this one? X minus 1. What's the common denominator going to be for down here? So I have x plus 1, x minus 1, right? Guys?
Yeah.
Now the numerator. Ain't that going to be 3x plus 3 minus x plus 1? So, this is going to give me x squared. Actually, let's go ahead and factor out this top part. Won't this be x plus 2x minus 1? Hold on, bro. I'm not done yet. I'm just doing the numerator. Now, down here, this is going to be 2x plus 4. So wouldn't that be 2x plus 2? Over x squared minus 1. Right? Or actually, you know what? Let's leave this as x plus 1 and x minus 1. For those of you who are saying so many steps, yeah, I know, that's sorry. That's advanced algebra. Now, stay, change, flip. Stay. Stay. Change, flip. And now, by. So I've got x minus 1 squared over 2x. Yeah, that would have never, we would have never gotten that answer. Yeah, we did it wrong. I did something wrong because it's so complicated the other way. This is the best method to do these super complicated ones. What do you want? The little page, you mean?
Yes. No, so you get the whole thing.
So yeah, you need split dual page. Yes, go ahead.
Whatever's like big numbers like 17 or like something.
I don't understand what you just asked me.
Like, will you ever see,
Will you ever see like?
really large numbers like on the original problem?
Like really large numbers like on the original like problem. 3 likes in one sentence. Yes, you can have any numbers you want, guys. Any numbers that I choose.
That's like 20 minutes.
Yeah, it would probably take you some time then. So I would suggest that you really start practicing. Why don't you guys write that one down and then we'll do one more together before the bell rings.
How about
You're only going to have 3 of these in the test. Shh. Okay, what is this one used for in real life? High level computer programming probably. Okay, and also to pass this class. This is, guys, shh. Algebra 2 and algebra and geometry and all that stuff works. It's used so you can build the common ground and the basis for really high-level mathematics. When you get into calculus, you need to know how to do this because this is just a simple part of 7 parts of one calculus problem, for example. Everything builds, okay? Okay, now, I'm just going to go ahead and... Okay. In calculus, problems take a long time, yes.
Teacher, please pardon this interruption.
Let me pause. Now, let me give you another one. This is a good type of question. This is a really good one. A lot of people get confused here. I'm going to show you how easy this is. When it gets really complicated, like something like this, gentlemen, I would definitely suggest doing it method 2. Okay? First of all, the denominator of the denominator here is 1. So the common denominator here would be x minus 3 times x plus 4. Do you really want to multiply 3x squared minus 4x minus 15 times x minus 3 times x plus 4? Do you see what I'm talking about? So in this case, method 1 would be horrible. Horrible. But method 2 would be great. The common denominator here is going to be x minus 1, x minus 3, x plus 4. So to this one, I multiply an x plus 4, because that's what I'm missing. And to this one, I multiply an x minus 3, because that's what I'm missing. So over here, the first multiplication, you got x squared plus 9x plus 20 minus x squared plus 3x, because it's a negative x that you're distributing, my brother. Okay? All of that over x minus 3 times x plus 4, which then I can simplify. This negative x squared and that x squared cancel. So I've got 12x plus 20 over x minus 3 times x plus 4, which I can reduce to, I could take out a 4, thank you. And I got 3x plus 5 over x minus 3 times x plus 4. That is simply the numerator. Now, the denominator. Let's go ahead and factor it. 3x, 3x. 3 times negative 15, and negative 45 is my new c. What times what is negative 45? Well, now together is negative 4. Negative 9 and positive 5. Artificial factors, so I've got x. Come on, Moro. So I've got x minus 3 times 3x plus 5. So x minus 3 times 3x plus 5. Is everyone with me so far? Is everyone with me so far? Who said no? Okay. So now, stay, change, flip. Stay. This is stay because this is all the numerator. Right? Change and flip. Remember, this is x minus 3 times 3x plus 5 over 1. So it'd be 1 over x minus 3 times 3x plus 5. Now, cancel, cancel. My final answer would be 4 over x minus 3 squared times x plus 4. And you do not have to multiply those out. Do you see that? Guys, I'm not saying this is going to take 2 seconds. I know it's a long process. I know that. But I know you can do it. And you have no choice, unfortunately, because this is what we're going to be testing on. You have your homework, which is going to be the following. Okay? On page 539 through page 541, you're going to complete 23, 25, 27, 29, 31, 33, 35. It's on a... Okay, guys, I'm so tired of repeating myself. I'm going to repeat it one more time, and that's it. If you don't learn it, you don't figure it out, sorry. And that's it. 23, 25, 27, 29, 31, 33, 35, 41, 42, 43, 44. Do 48 as well. And that's it. God bless you. Have a great day.